Hi, this is Shiv Kumar here, and today I am going to teach here probability. Before moving to that, I will tell you about myself. My qualification is Master of Engineering in Thermal Science, and my area of interest is mathematics. So every time they are asking 2 to 3 questions from probability. Let's start that probability here. You see, the probability of any event of an event is defined as favorable outcomes by sample space. And here I indicated the favorable outcomes is M and the sample space is N. So here M could be and equal to N. M means M is less than and equal to N. Correct. So if I'll say here like a coin is there, unbiased coin. Unbiased coin means there will be one side head and one side tail. But if you assume that a biased coin means it will be both side head or both side tail. Correct. So I can say that if I'll tell you like a biased coin, what is the probability of getting a head? What is the probability of getting a head? So we can say that the sample space is 2 and the outcomes will be also 2 here because both the side is head. So 2 that is equal to 1. So probability of any event, it could be equal to 1 also. But if you take an unbiased coin means one side is head is there, another side tail is there. Correct. So if I take a sample space, the sample space will be either head or tail. If you toss the coin, it will come head or tail. But if I wanted to find out the relative probability of getting head, it will be 1 by 2 because the favorable outcomes is only one times out of 2 times, it's a 1 by 2. So I can say that the probability of any event, it could be equal to and less than n, where n I assume that it's a sample space and m is here favorable outcomes. So here the next thing is the probability of any event that could be greater than and equal to 0 but less than and equal to 1. That is possibility is there. Here we saw that possibility. So first of all, we will discuss that sample space of all types of event. So first we took that here unbiased coin. And if you toss an unbiased coin n number of times, the sample space will be 2 raised to n. Because 2 indicates that one side is head is there, other side is tail is there. Correct. So it's a 2 raised to n. Similarly, if you take it here n is equal to 1, then you will get the head and tail. That is the sample space. But if you toss n is equal to 2 times, like if you toss coin 2 times, see first time it could be head, second time also it could be head. First time head, second time tail, or first time tail, second time head, or both the time it could be tail only. Correct. So the favorable here sample space, I can say that it's a 4, or else you can find out 2 raised to 2, it's a sample space. Same way n is equal to 4, if you toss it here, the 2 raised to 4 means it's a 16. It's a 16. So there will be a 16 sample space. So you remember that if you are tossing an unbiased coin, then the sample space will be 2 raised to n. Similarly, if you are rolling a die n number of times, so it will be 6 raised to n. But in dice, there is a number from 1 to 6. So that's why we are saying that 6 raised to n. So n is equal to 1 means that can come up any of the number like 1, 2, 3, 4, 5, 6. But if you toss it, n is equal to 2 times, it's a 6 square, 36. 6 square, 36 means if you 2 times, if you are rolling 2 times, first time it can come up 1. Second time also it can come 1. Your first time 1, second time 2. Your first time 1, third time 3. So it can go up to 1 to 6. Or else first time 1, 2, second time 1. Your first time 2, second time 2. So it can go up to 2 to 6. So similarly, you have to go from 6 to 1 to 6 to 2, 6 to 6. And in total, I can say that there will be 36 sample space. So this is for rolling a die n number of times. So that one you keep in mind that 6 to power n. So here, like if I'm tossing a coin, tossing a coin 3 times. So if I tell you what is the favorable outcomes of getting head exactly 1 times, what is the favorable outcomes of getting head exactly 1 times? To see 1 time head and 2 times it should be tail. That is my favorable outcomes. It should be 1 time head and 2 times tail. So see this letter, how many ways we can arrange it? 3 factorial divided by head is 1 time, tail is 2 times. So divide by 2 times. Divide by 1 factorial into 2 factorial. And this one we can write down as a 3c1. So that combination comes from here. That is from arrangement only. Correct. So here, if I am tossing a coin 4 times, correct. So if I tell you what is the probability of getting 2 head, So first of all, you need to find out favorable outcomes. Correct. So there should be a 2 head. Out of 4 times. So that head and tail. 2 times head and 2 times tail. So this letter we can arrange it by how many ways? 4 factorial divided by 2 factorial into 2 factorial. And this one we can write down as a 4c2. So we can apply directly combination in probability. Correct. In a case of dice also, if you are rolling a dice 6 times, then what is the probability of getting a number 6 times 6? 6 times 6. So we can apply the combination property there also. Correct. So the sample space for coin case and dice case, we saw that here. Now come for the sample space for card. So there is a total 52 cards are there. In that there will be 2 colors, black and red. Again the black will be 26, red will be 26. Again the black is divided into 2 types, spade and club. Spade will be 13, club will be also 13. And the red is divided into again 2 types, heart and diamond. So heart and diamond will be respectively 13 and 13. Correct. So you have a 13 cards. That is starts from A to K. And each card is 4. So I can say that 13 into 4 is how much? 52. So in that, they can ask the question from like face card. How many are the face card? The face card, I can say that Jack is the face card. Queen is a face card. King is a face card. Correct. So total is a total 12 card or face card. But if I say what is the honor card? Honor card means respected one. The respected one means king, queen, jack is already there. But in that the ace is also included. Ace, ekka is also included. So total is a 16 cards are there. Honor card. Correct. So we will see that these are the sample space for coin, dice and cards. So for coin case, we saw that the sample space is 2 raised to n. For dice case, it's a 6 raised to n. And for card case, it's a 52 card. In that, you have to know that how many are the black, how many are the red, how many are the heart and diamond, and spade and club. How many are the face card, and how many are the honor card. Correct. So we will move it to that next. We will solve the questions based on that. So before moving to the questions, first of all, we'll check the addition theorem for dependent event. What is a dependent event? The occurring of event A affects the other event, that is a B. So those two are like dependent event. So I'm assuming that let's say that the dependent event having a sample space S, and this is the event A and this is the event B. So this part is called intersection part. That is a common event. And this full is called here, it's a union, A union B. And this part is called here, it's a only A. This part is called only A. Only A, you can indicate that A intersection B bar. Correct. Similarly, you can indicate this one as A bar intersection B. So in that, this is called only B. Only B. So how can you find out the only A? The only A will be equal to probability of A, in that you subtract that intersection part, A intersection B. So that will be only A. And this total is A is there, in that you subtract this is intersection or common event. You can get the A intersection B bar. This one is called A bar intersection B. So this one you can find out by P of B minus P of A intersection B. A intersection B. And this itself is a here This one itself is a intersection B event. But if you wanted to find out the total P of A union B, so that will be equal to P of A plus P of B, P of A and P of B. So while counting P of A and P of B, you are counting twice. This common event, you need to subtract one time. So that will be total equal to P of A plus P of B minus P of A intersection B. But if you are saying that if A and B are mutually exclusive events, mutually exclusive event means there is no common event between them. Correct. So in that case, it will be equal to 0. So that one will reduce to P of A union B is given as P of A plus P of B. And union means always remember that it's a OR. And OR means if it is saying that, it means it's a plus. Similarly, we can tell it like that for 3 events, it will be P of A plus P of B plus P of C. So like we have taken one example in a card of 52. What is the probability of drawing a king or queen? We have to find out a king or queen. So find out the probability of getting king plus find out the probability of getting queen and add them, because those two are mutually exclusive but having a same sample space. So how many kings are there? So there is a 4 kings are there. Out of how many cards? 52. How many queens are there? There is a total 4. 4 king means 1 spade, 1 club, 1 diamond and 1 heart. Similarly, for queen is also club, spade, diamond, heart. So it's a 4 by 52. So it will be equal to 4 1 ja 4 into 13. 4 1 ja 4 into 13. So the answer will be 2 by 13. So here I can apply the addition theorem. Correct. In a similar way, if you move it to that next is a multiplication theorem for dependent event. Let us consider that A and B are the two dependent events are there. So here we can apply the conditional probability. Conditional probability, what it says that P of A by B is given as P of A intersection B, means there is a common event divided by PV. Where P of A by B meaning is probability of occurring of event A when B is already occurred. So we are finding the probability of occurring of event A, that is in present case, when the B is already occurred in the past. We can apply the conditional probability. Condition. Similarly, if PB by A is given as P of A intersection B divided by P of A. So there is a use of this one in multiplication theorem. What is the use? So if you assume that if A and B are independent events having the same sample space, so I can write down P of A by B is a P of B itself, or else P of B by A is P of B itself. P of A by B is a P of A itself, not PB. Means just in numerator, and whatever the B event will be here, it will be B. It will be B only. Means it won't depends on A here and it won't depends on B because they are independent events. Correct. So we can go by the multiplication probability. Multiplication P of A by B, I can write on P of A intersection B divided by PB. So P of A by B, I can write on P of A itself because it does not depends on B. That must be equal to P of A intersection B divided by PB. So from there, if you do the cross multiplication, so P of A intersection B, we got it P of A into P of B. This is called multiplication theorem for independent events. Means if it is intersection means you need to understand that and means what? It's a multiplication. And means what? It's a multiplication. So here I took the example, 2 cards are drawn one by one from a pack of 52 cards. What is the probability of getting first card is S and honor card, and the second one should be honor card, and there should be a no replacement. Correct. So we can find out here easily for this one. There should be first card, it should be honor card, no S card, and the second should be honor card. So there is a and is there in between them, and means what? It's a multiplication. So that's why I have used here intersection. So we can say the probability of getting a S card into probability of getting a honor card. And it's a without replacement is there. It's a without replacement. Means whatever you are drawing the card, you should not keep it again. So what is the probability of getting S card? So it will be 4 by 52 into one card you have taken out. From 52, one card you have taken out. The remaining is how many? 51. So next time the sample space will be 51. And how many honor card? It will be 13. Because one king you have, one S you have drawn that. So there is only 3 S is remaining. 3 S and 4, 4, 4 is king, queen and jack. So total it will be 13. So 13 by 51. Correct. So you need to multiply this one 4, 1, 4 into 13. This one will be equal to, this is a 15, not 13. It's a 15 because total honor card will be equal to here 15. So 3 5 is 15, 3 into 17. Correct. So 5 1 is 5 divided by 13 into 17 is given as 221. So your answer will be C option 5 by 221. Correct. In a similar way, we can go for the next. This is the most important for IIT JEE, Bayes theorem. Mostly they will ask the question from Bayes theorem only. Correct. So the Bayes theorem, what it says that Bayes theorem is actually reverse probability. Reverse probability you can better understood by the problem. Look at here. Let S is the sample space and E1, E2, E3 are the mutually exclusive event. It means there is no common event among them. There is no common event among them. Then we can find out P of EI divided by A is given as P of EI into P of A by EI. It means see, you can check it from these two term. Those two are reverse. Those two are reverse. So that's why we are calling it as a reverse probability. And this down one indicates the total probability. This down one indicates the total probability. So how can you use it? This one. Look at here, everyone. See, question number 3. In a bolt factory, a machine ABC manufacturer respectively 25%, 35%, 40% of the total product, total bolts. And the machine A is producing 25%, machine B is producing bolt 35%, and machine C is producing it's a 40% of the total bolts. Out of their outputs, 542% are respectively defective bolts. So what you do, you assume that there is one event is there, and that event is defective product. Defective product. So that event I'm assuming that D. So that defective product that is found from machine A, the defective product is found from machine A is given as how much? 5%. Machine B is 4%. And for machine C is it's a 2%. So this one is written like that. That machine A, B, C is already produced the bolt. Now after producing, we are going to select a one bolt, and that bolt probability is given 542% from A machine, B machine, C machine. Correct? These are that is a conditional probability you need to apply. A bolt is drawn at random from the product and it is found defective. From total product, one bolt is drawn. Correct? And it is found a defective. Correct? Find the probability that the bolt produced from the machine A. So that we already got it here, probability of defective product from machine A is 5%. He is asking that bolt drawn from the machine A. He's asking that probability of A by D. Probability of D by A, we already know that. That is a 5%. He's asking the probability of A by D. That defective found from the machine A only. That is produced by A. So that one you can write down probability of A into probability of D by A. Write down that one divided by total probability. Total probability we can write down as a probability of A into probability of D by A plus probability of B into probability of D by B plus probability of C into probability of D by C. The probability of A is how much? It's given as 25, 5, 25% into 5%. into 5 divided by here also 25 into 5 plus B is given 35 and 40, 4 and 2. So write down here 35 into 4 plus 40 into 2. It's a 125 divided by 125 plus 140 plus 80. It is equal to 125 divided by 140 plus 80 is 220 plus 125 is 345. You can divide them. 5 to the 10, 5 5 ja, 5 6 ja, 5 9 ja. Correct. It's a 25 by 69. 25 into 5 is 125. So 5 it will get cancelled by 25 and 5 6 ja, 30, 5 9 ja. That's the answer is 25 by 16. This is it. So this is a reverse probability or base theorem. We can solve it to one more question. Look at here. A bag contains 2 white and 3 red. There is one bag is there. Let's say that this bag is A. In that there is a 2 white and 3 red balls in there. Another bag B is here. Another bag B, 4 white and 5 red balls. 4 white and 5 red balls. One ball is drawn at random from a randomly chosen bag. So one ball is drawn at random from randomly chosen bag. So in what is the quality of choosing a bag A or B? So there is a 2 bag is there. We can select a bag A, that is a 1 by 2. Similarly, the probability of selecting a bag B is also 1 by 2 because total 2 bag is there. Now a ball is drawn at random and from the chosen bag and found is red. So your event is red ball. That is your event, red ball. So I can say that what is the probability of getting a red ball? What is the probability of getting a red ball from bag A? This is nothing but probability of getting a red ball from bag A. So bag A, how many red ball are there? 3. So it's a 3 by 5. Same way probability of getting a red ball from bag B. It's how many? 5 by 9. So I have to find out what? The probability that it was from bag B. It means is asking B by R. That is called base theorem. It is found from bag B. So that one we can write down simply. Write down P of B into P of R by B divided by P of A into P of R by A plus P of B into P of R by B. Down you need to write down the total probability. So P of B is 1 by 2 into 5 by 9 divided by P of A is 1 by 2 into 3 by 5 plus 1 by 2 into 5 by 9. If you simplify them here, so this would be 5 by 18 divided by 3 by 10 plus 5 by 18. So if you take the LCM of the denominator, this is the 5 by 18 and here 18 and 10 LCM is 90. 10 9 is 9 3 is 27. 18 5 is 25. It's a 5 by 18 into 90 divided by it's a 52. So this one 18 into 5 it is get cancelled. So 25 by 52. This is my probability of getting red ball from bag B. So your answer is 25 by 52. We can check it one more question because mostly they will ask the question from base theorem only. A man is known to speak truth 3 out of 4 times. So speak truth is 3 by 4 times. And I can say that speaking lie is nothing but 1 by 4 because 3 by 4, 1 minus 3 by 4 is 1 by 4. Now he throws a die and report that it was a 6. So your event is what? Getting 6 from a rolling of die. So what is the probability that it is actually 6? Actually 6 means it's a truth. So first of all, find out the probability of getting 6. Let's say that the event is E when he is saying the truth. Because if you throw the die, whether it is getting 6 or 4, we don't know. But that boy is saying that yes, it is just 6 is there. Then what is the probability of getting a 6 when he is telling truth? It's a 1 by 6. Because there is total 6 numbers are there. And that the only one time will be 6. And if he is telling a lie, then what is the probability of telling a lie that it is not a 6, but that is a 5 by 6. But he's saying that what is the probability that it is actually 6? It is actually 6 means he's asking T by E. Actually means what? It's a truth. Means the boy is telling truth. Yes, it is a 6. Blame me. So that is equal to probability of T into probability of E by T divided by probability of telling truth into probability of E by T plus probability of telling lie into probability of E by L. So substitute that. So probability of telling a truth is 3 by 4 times. Getting 6 is 1 by 6. That is truth. 3 by 4 into 1 by 6. Probability of telling lie is 1 by 4 into telling lie is 5 by 6. So 3 by 24 divided by 3 by 24 plus 5 by 24. So you can resolve them. 24 will go up and 5 plus 3 is 8. That's the answer is 3 by 8. So your option number A is right. Correct? In a similar way you need to do. Like we have another question also that is based on the same concept. Player A speaks the truth 4 out of 7 times. And it means you will tell a lie 3 out of 7 times. Because total is 7. 4 times is telling the truth. Rest of the 3 times you will tell the lie. Now a card is drawn from a pack of 52 cards. Okay. And he reported that there is a diamond. So how many diamonds cards are there? So total is a 13 are the diamond card. Club, spade, heart, diamond. So each one will be 13, 13, 13. So here the event is what? Event is getting a diamond card. So what is the probability of getting a diamond card when he is telling truth? So let's say that the event is E. When he is saying truth, it means total is a 13 diamond card out of 52. It's a 1 by 4. 1 by 4. So what is the probability of getting a diamond, not getting a diamond card? Not getting a diamond card means it means is telling lie. Is telling lie. So what is the probability? It will be 13, you remove it from 52. It's a 39 by 52 and it we can say that it's a 3 by 4. Or else from here you subtract, that is a 1 minus 1 by 4. You will get the 3 by 4. Then what is saying that what is the probability that actually there was a diamond card? Means it's a truth. Actually there was a diamond card means you need to find out P of T by E. So that one you can write down probability of telling truth into P of E by T divided by P of T into P of E by T plus P of L into P of E by L. Correct. So P of T is telling truth is 4 by 7 and E by T. Probability of getting a diamond card when he is telling truth. Probability of getting a diamond card when he is telling truth is 1 by 4. And probability of telling a diamond card when he is telling truth is 1 by 4. And probability of getting a diamond card when he is lying. So it's a 3 by 7 into 3 by 4. 3 by 7 into 3 by 4 is just 4 by 28 divided by 4 by 28 plus 9 by 28. So I can say that 4 by 28 into 28 divided by 13. So the answer will be 4 by 30. Option number D. So these all are the problems are there. Mostly in IIT JEE, they will ask the problem from base zero. Correct? Fine. So thank you.